Okay, hello everyone. We usually have a slight delay in the beginning, so let us go. Okay, I guess we're all done. Just let me do a very quick check for the microphone. Just give me 1 second, please, and we will continue. Okay, so welcome everyone to this evening session of PyLadies Amsterdam. For those who joining us the first time, I will give you a little bit more information about us in a bit. And for those who is joining not the first one, then you know more or less what's going to happen next. So let me briefly introduce PyLadies Amsterdam. We are a nonprofit, a part of the global PyLadies network. Focus of PyLadies Amsterdam chapter is mostly on delivering workshops to you. And today is the workshop day again. Despite the very, very bad weather in the Netherlands, we have a wonderful speaker for the, let's say, from the very, very sunny location, and I will announce the location in a bit as well. So a little bit of house rules before we start. If you have any questions, for those who are in Zoom with us right now, just ask your question in the chat, and as soon as it goes, we will answer them. If you are, let's say, just a second, we have some issues with the sound. Just let me quickly check one thing. Okay, sorry, just checking the sound on the YouTube. There were some issues with that so far. So a bunch of house rules. I mentioned if you have any questions, ask them in Zoom. If you're watching us from YouTube, we also can help you and answer some of your questions, but we cannot guarantee immediate response as we do with those who are in the Zoom with us. I think that's it for now. And I think the additional thing on top of the thing butter with butter, sorry, it was a very long day for me today. We had a very, very, very unique person today. I have an honor to meet Valery in person 2 times eventually, once at EuroPython at PyLadies stand, and the second time at PyCon Spain. So I'm very, very happy. And I was spending a long time talking to her and saying, Valery, when finally you're going to give a workshop with us? And back then she was living in Madrid, Spain. So I was like, hey, tiny time difference between. But now Valery relocated, if I may I say where you relocated back to? Okay, so now Valery relocated back to Mexico, which means that for us it's evening now, but for Valery it's the morning, or I would say rather early morning. So we're very grateful that you are with us today. I think the floor would be yours now. So please unmute yourself and you can continue to moving forward.
Thank you very much. First than anything, thank you for the invitation to give a workshop. I was also excited to give a workshop. Like before maybe, but since I moved of continent, it was a little bit hard months. But now we are more settled. So yeah, I'm very happy to be here sharing with you all. So, okay, let's go to the topic. All right, so we are gonna talk today and learn a little bit more about Smallpond. I think a lot of us heard a lot of hype a few months ago that DeepSeek, that DeepSeek have also had his own hype And one of the key tools that they use for building their AI tools and everything, it's a Smallpond. So it is kind of, it takes a lot of attention on how they are doing these things, because we know that they are using small resources and yet nailing it. So yeah, it is a very interesting topic. It's also fair to say that in this workshop we are gonna see just like the entrance to how to use this tool and how it works. We are gonna focus more on how it works, and not only the advantages, but also the limitations that it has. Mainly because it's something that, at least what is shown to the public, is not so much like it doesn't have a lot of time being built. It looks like, like it's in the early stages, right? So I think it has a lot of future in the to keep growing, but in the current status that we can see, because we don't know if they are building it still growing, but privately, we don't know. But open source, what we can see is still a little bit limited. But we are gonna dig into it, and we are gonna put our hands on the dirt to understand how it works and how we can use it. Okay, so before I start with the topic, I want to introduce myself. So as Una said, I'm living in Mexico right now. Previously, I was living in Europe, so I was co-lead of PyLadies Madrid previously. And before that, like a long time ago, I was still living, I was born and raised in Guatemala. So I founded the Python Guatemala community. And well, you can find me on any social network as Valery Briz. And after this workshop, if you have any questions with the material or anything, please, you can also contact me there. Okay.
And if I may interject very, very quickly, sorry about that. So I'm going to share, of course, as soon as Valery going to move through the workshop, I'm going to share the link to the repo once again, so you don't need to look for it up for it. So in case you're going to face any challenges with installations, or you haven't thing installed yet, we will see how much time we do have. So probably we're just going to continue with our workshop, but please keep in mind this workshop is as we speak, it's recording and streaming right now, which means the video record would be available after this. We're also going to add timestamps for more easier navigation. So if you're going to face some installation challenges, probably we will not have time to fix it right now during the workshop, but afterwards you can get back to us and we're going to help you. And you all also can rewatch the workshop again. Sorry, I will give you floor back, Valery. Thanks.
No worries. Thank you. Okay. So what is Smallpond? Smallpond is a lightweight distributed data processing framework. What does it mean? It is meant to transform data, but really big data that we have. And in order to be able to feed this data to, for example, to feed an LLM, to feed another tool like a data warehouse. And actually the key analytics, like business logic, it is not so much, a Smallpond is not so much meant for like last mile analytics, right? So it is more built to transform data, like filter, like basic transformation of data in order to clean up, in order to make it ready for next layers of processing. So, and what does it mean that it is distributed? we're gonna see deeper later. We have some graphs also, so we can see how it works. But distributed means that basically we will have multiple machines that will execute DuckDB. So what Smallpond uses is DuckDB to execute this transformation to the data. But DuckDB, if we just used the library, it will be executed just in our system or in our cloud compute. But in the case of a Smallpond, it is available to distribute through multiple machines, depending on the need. So yeah, basically what it does is parallelizing the processing of this information in order to make it quicker, but also it is pretty simple to use. Everything can be installed, like it doesn't need a huge configuration, it's like very, very simple. And the resources can go from small resources to a huge amount of machines with GPU and everything. So that's kind of also another very key thing on Smallpond, that is flexible to scale out and in. Okay, and why is interesting? Well, first, what I just said, that is, it can be distributed. So that makes us that puts easier our way to scale in and out, because sometimes when we are building new infrastructure and we need to decide on the platform or the tool that we are going to use, we want to say, okay, I'm small right now, right? Like this is a small company, a little bit small data right now, but we want to build something that will last also for a scale up. So this tool is something that can be flexible that way, and it's open source, right? So we can build these kind of systems that maybe it's going to work with smaller data in the beginning and little by little scale up, though it is meant for big data. Okay, it's if you just need to run small scale, and that in some time you will keep just transforming small amount of data, then maybe it's not your tool. Okay. And another interesting part is that it uses 3FS, which is another tool that was built by DeepSeek. That one is on a more mature status, 3FS, and it is very performant. So that's also a good advantage of Smallpond. We are going to go also and see deeper 3FS later. Um, and finally, we are able to do manual partitioning, or Smallpond can do some basic partitioning. But if we know our data and we know how we can divide it, then we can manually say, okay, I'm gonna partition this by the date, by hash, etc. And that will all be executed and distributed by Ray. We are gonna see that Ray is key here. Is our key tool used by Smallpond. Okay, and so let's get some context on the backends, let's say, of on the functionality of Smallpond. So as I said, it uses DuckDB, which DuckDB is a in-process analytical database. So it means that we are gonna install it like any library in Python. We're we are gonna install it as a dependency. And once it is installed, we're just gonna use it, like we use pandas or any tool like that, but we can use it with SQL. So it is pretty flexible also. As I said, very easy to install. We don't need tricky configurations or anything like that. So it's just install the library and start using it. So and it is pretty performant. So that's why Smallpond is using it. Then another key part is the 3FS, the Firefly file system. And this is a high performance parallel file system. And it was designed to for their AI project and to be high performance, like really, really high performance. So for that, they use SSDs, the solid state disks, which are faster than the old HD disk. And they also use this RDMA, which is remote direct memory access networking, which means basically that if you have multiple nodes or multiple machines in a cluster, and all of them have the data that you need to use, they are able to, through one network, move the data from one place to the other. So it's something like if you had an external disk connected to your computer and you're able to access pretty fast the information in the disk, in the external disk, right? But this external disk is actually another machine, right? So they can configure this access to the file system in a way that looks like accessing an external disk, even though it's machine to machine. Okay, and to give an example of how performant it is, TFS has hit 6.6 terabytes per second read through a 180 node cluster. So imagine that you transfer 6.6 terabytes from one machine to the other in 1 second. So that's pretty fast, right? I mean, obviously, it doesn't mean that you're going to use it just with two machines, two work nodes. It's a 180 node cluster. So it's a big cluster, but still, they were able to get into 6.6 terabytes per second, which is pretty fast. So yeah, that's another key part of Smallpond. And then we have Ray, which I think is the most important part of Smallpond. I mean, the 3FS makes it really fast into writing the results when you transform the data and everything, and reading the results. But without Ray, we won't be able to distribute the tasks. So Ray is not built by DeepSeek. It was built open source outside that project. And they use it basically to be able to execute DuckDB in different machines, okay, in different work nodes. So it is Ray is also available to have a robust management of this cluster. So if any of the workers fail, it is the manager can restart the node and to keep executing the transformation. So it is fault tolerant. And it can use either CPUs or GPUs. Okay, so we are able to decide how much power we want to put in our cluster. And it also has unified APIs, so you can like communicate to Ray through the API and two different frameworks, so that we can use it with multiple situations or multiple processes. Okay, so that's very key on Smallpond to use Ray. And finally, we are using MinIO in this workshop. This is not part of Smallpond, okay? This is completely outside of Smallpond, but since I didn't want it to have like a requirement of having a cloud bucket like AWS or Google Cloud Storage or something like that, then we are going to use this open source platform, which is MinIO, which basically works exactly the same as Amazon S3. Okay, so we can even use Boto, which is the official Amazon S3 library to interact with the storage. Okay, so we're gonna use it as our storage system, basically. But this is not part of Small. Okay. Um. Okay. And okay. And how does Smallpond works? Okay. So in a general way, like seeing it from above, what Smallpond does is it will create a session, right? Something like a Spark session that will gather the configuration for that run specifically, okay? And this session, first, I mean, when we code some tasks or some execution of transformation in Python, what this session will do first is gonna create the logical plan, you know, like, okay, first I'm gonna uh, ingest the information from the storage system or from the source with the 3FS, right? And once I have it on cache, on RAM, then I'm gonna execute, for example, this filter. Okay, so we're gonna filter this information and that will create a new data set. And with the new data set, let's say we're gonna apply a map. And after this map, I'm gonna have the result done, okay? Then what Smallpond will do is to consider the partitioning or the optimization of how this plan could be executed. If we manually added the partitioning, then, for example, if we say, okay, I want you to partition it by date, then is this point where we are gonna say, okay, I'm gonna execute it in the workers, partition it, you know, divided by the date. So it's gonna be every single filter or like the general filter that we applied in the logical plan is going to be executed, divided in the workers by this partition that we saw. And the optimization that Smallpond itself is going to do inside. And once we have ready the full plan on, okay, we know how we're going to do it, then it will communicate to Ray Head, which is the manager of the cluster distributed. Then it's gonna Rayhead is gonna divide the tasks and the workload into all the workers that are available. Okay, so it will look like this. I mean, I have two workers here, but it's more like an example that we could have from worker number 1 to worker number n, right? We can have as many workers as our resources and our configuration of how many resources each worker is going to have will permit, right? So we could decide here when we create the Smallpond session, we can decide how much RAM and CPU, how many nodes each worker is gonna have, okay? And once the workers have the tasks that they need to run, simply what is gonna happen is we can see the worker as a machine, right? So this machine is gonna execute DuckDB and it's gonna execute the actual filter, the actual logical plan that we had in the beginning, and we'll gather the result of this. And this result, there's two options to get the result. The first option is just to write it to the disks with 3FS, so pretty fast, right? And the other option is that we use some action like collect. And in this case, collect will let us see the result directly like a print, right? We are gonna see the result in our local machine or wherever we are executing this from, the Smallpond session. So that's basically how Smallpond works. Okay, and now how does it look like what we are gonna do in this workshop? Okay, our infrastructure. So what we're gonna have is array distributed with two workers. We're gonna use just two workers in this case. And let's remember that array head to connect and to send and receive data from the workers uses S3 3FS, sorry. And we're gonna have Smallpond installed in our environment. Okay, so that's why it looks like it's like separate from our Ray cluster. And this Smallpond session is gonna be run from a Jupyter notebook. Okay, so we're gonna install Smallpond and Ray and MinIO libraries in our environment in Jupyter Notebook. And from there, Smallpond will point to the machine that is the Ray head. And also, we're gonna be able to interact with MinIO, which is also in another machine, Dockerized. Everything is gonna be Dockerized. And yeah, that's basically how our infrastructure is gonna look like. As you can see, it's pretty simple. I mean, even though if we had like a huge amount of RAM and CPU cores, we were able to, with this same infrastructure, execute terabytes of data, right? It depends actually on our resources, but the configuration is pretty simple. All right. And lastly, a disclaimer, because as I said in the beginning, Smallpond is in a very early stage status, at least what is open source is in a very early stage. So the documentation, if you go to Smallpond's GitHub, it has like a few examples, and it doesn't even really tell you how to connect with Ray. That's why I wanted to make this workshop, because it's, you know, a little bit of what is missing there in the documentation. So you can get started with it, but it's pretty obvious. I mean, we can see clearly that it's missing a lot of things. And perhaps if we want to do like complex transformations or that kind of things, is not gonna be, perhaps it's not gonna be implemented. Like we don't have as many methods or actions as we can have in Spark or as we can have in Pandas. But that remembers ourselves that Smallpond was created just for kind of the first layer transformation, like transforming raw data with the flexibility of Python and DuckDB into a cleaner version of the data, just there, not complex analytics, not last mile business logic, nothing like that. It was built just to clean up the data and then going through other processes, being able to feed an LLM, right? That's what they did with this tool. So yeah, it's just a disclaimer. You will see that perhaps there's not so much to, the options that we have in Smallpond are not so much. But the idea of this is to try it out, make it work, and from there, understand how we can use it. Okay, so I'm gonna go outside this.
And while you're doing
And
that, meantime, I'm
Mhm.
sharing the repository in chat as well.
Okay, awesome. So in the repository that you are able to check right now, what we have is this in the README. In the README, you can see the requirements. So I will suggest that we go first there. Okay, if you haven't installed previously these requirements in your local computer, then let's install it first. So very basic, we need a virtual environment, a Python virtual environment. We recommend UB so that you can install it. So after cloning it, you can simply UB sync in order to create the virtual environment and install the dependencies. But if you use other virtual environment tool, like for example, I use PyCharm, so it already gives you a virtual environment, then you can just still install the UB and sync like inside this environment that is already created. And then very importantly, we need to install Docker. I suggest to install Docker Desktop, which is easier. You can go down here, and then here you can choose if you're using a Mac, a Windows, or Linux. And just install the desktop because it has everything that you need. And otherwise, if you're gonna use Google Colab, then you can follow these instructions to have the code and everything that we need there. Just a disclaimer that if you use Google Colab, sorry, you won't be able to run Docker, Compose, and the infrastructure basically, but you will be able to run the specific notebooks that are made for Colab, okay? Here in the workshop and then notebooks, you can see that the introduction is the same for everybody, but then the Smallpond in Colab and the practice in Colab are specific for Google Colab, okay? They are kind of simpler. If you run Smallpond in Colab or in a local machine without a RAID cluster, then you will see that it's pretty slow, like lower than pandas even, okay? So that's also something important to have in mind, that in order to make it work blast fast, you need to have the enough resources and array cluster up, right? So, but still, in these two notebooks, we can see how to do the things, okay? So, let's see if I'm missing something here. I don't think so. Yeah, we have all the instructions here. If you have any questions, please write to the chat in Zoom so that we can answer back. And yeah, and you have the presentation here. Okay, let's go to the environment. All right, so perhaps right now you're installing the virtual environment and the Docker Compose. So then after you have installed everything on the requirements, you can see the README here. Let's go. Ah, no, sorry. It's in the notebook, in the introduction notebook. Yeah, here. Okay, I'm gonna move this so we can see it clear. All right, so the first notebook that we're gonna use that is actually for setting up everything before we start running, it's introduction. Okay, so you need to go to introduction and we can see, I mean, here I also added some info. If you don't use UV, you can also follow these instructions to create the virtual environment. And very, very important, you need to have Python 3.11.11 if you're running it locally and you're gonna run all the infrastructure in Docker and everything, okay? This is very important because Ray, the Ray version that we have in the Docker that will deploy Ray here is using Python 3.11.11, okay? If you use, let's say, Python 3.8 in your local machine and you want to communicate to Ray, which has Python 3.11, it won't work. Even if you have Python 3.11.36, if it is not 11.11, then it won't work. Okay, this is key. This is because Ray is also using Python, and in the communication, it tries to see the compatibility of the code that you're gonna execute there, right? So pretty, pretty important having the same Python version in your local computer as it is in the Ray. Okay, so once we have our dependencies installed, here you can also see the Docker desktop. I already have my Docker running, so you can run your Jupyter notebook. I'm running it. I mean, I added the instruction here, but you can also, for example, PyCharm already gives me a Jupyter Notebook kernel, so I can run it from here. But if you don't, then you can also run it like this. Oops. I'm adding everything. Let's remove all these. Okay. Okay. So if we run this, we should have a Jupyter Notebook in the terminal, I don't know, in the navigator. So here we have our Jupyter Notebook. We should be able to see all the folder and the files that we have in our repository, right? The same as we see here. Okay, so very important that if you run any command that is written here to be run in the bash, it needs to run inside workshop. Okay, so basically what I'm gonna do is I'm gonna cd workshop. Okay, as you can see now I'm right here where all these folders and files are, and I'm gonna run, for example, just to double check that everything's fine. I'm gonna run Docker page. Okay, so if this is after you install Docker desktop, then you can run these to double check that you have already Docker and Docker Compose. Okay, here we can see it is ready. Okay, and if it is the first time that you're gonna build the Docker, you can use Docker Compose build. Okay, and then to make it deploy the container, you can use Docker Compose up -d. The -d is to detach, so it will run the logs and everything of each machine, each service of Docker in the background. So we won't see all the logs in our terminal, okay? And if it is the second time, or if we need to change something because I don't know, it happens that in my machine I need to change something here to make it work, okay, then we will just use Docker Compose up -d build. So this will just rebuild the image so that we can be able to get the last changes and run it again. Okay, so I'm gonna run it from here because I have it already here. Okay, I'm gonna set it up. Since I already have it downloaded, as you can see, it was almost ready to be deployed. And you should see something like this, which is we have two workers of Ray. We have the Ray head. We have the network, which is a Smallpond default. We have MinIO. And well, and this is just a double check that the containers are up and running. So if we want to go deeper in what is being built and deployed, we can go to the Docker Compose. Okay, you can find the Docker Compose here in the root of workshop. Okay, and we can see here we have 4 services. First, we have the MinIO, which is just a pool of the image, of the official image of MinIO. And we are gonna have 2 ports exposed, okay? 9000 and 9001 for the API and for the console. So if oh, and also very important, we have the volumes. This is why we have this folder here. Okay, and yeah, and we are setting up the user and the password of the service. Okay, so if we go to localhost 9001, we should be able to see this dashboard, okay? And we are gonna use the same credentials as here, MinIO admin. Obviously, this is a local test. Please don't use these credentials for development or production. This is just a local test. Okay. All right. So we are here. So in the case this is the first time that you are running this, you won't see any buckets. Okay. So there are two ways to create the buckets. We are gonna see how to create it in the Jupyter notebooks. But also you can create it manually here in the UI, okay? So I don't know if it is fine. I'm gonna zoom in a little bit just in case. Okay, so you can create a new bucket like this. I'm gonna put just a fake bucket. And inside the bucket, we can even upload files and everything. All right. And from here on, we can start interacting with these buckets and files as we could do it with the AWS or Google Cloud Storage. All right. So let's go to the introduction notebook that we are seeing. Okay, so we are over here. We have built the Docker Compose. We have it up, right? So the setup should be up and running. So this is the first check. Having MinIO ready, accessible, and that we can create buckets and files, okay? All right, so if it is running fine, we can go to the next service, which is Rayhead. So Rayhead will be the manager of the cluster, all right? And this over here is the command to run Ray. We will set up the port for Redis. We will set up the port for the dashboard to be accessible, and the gRPC port for client connections. It's very important that we have all these ports exposed so that every service that will interact to each other in this Docker setup are able to connect to each other. Okay, so yeah, basically that. And then in the environment, it is also pretty important that we share the credentials to interact with my MinIO. Okay, and yeah, and we are setting up that this is the Ray head. Also here we are executing Ray head, okay, because we use the same image. We can go, if we wanna check out how Ray is being deployed, we can see the specific Docker file. Okay, I basically use the official Ray project image, but I wanted to have a specific Ray machine, which is Python 3.11.11, and then setting up the working directory for the service, and installing the requirements so that it can communicate with Smallpond without problems. Okay. All right, so let's go here, down here. Ray is gonna access this folder called data, okay? And in the service side, it will be this root Ray data, but it's basically the same folder. Okay, and after that, we just have the two workers. So basically it's the same as in the head, but we will start Ray in a slightly different way, and we will point to the Ray head here in this port, in the Redis port, okay? So that they can be connected to each other. And that's basically our infrastructure with Docker Compose. So now, if we have finished install and downloading everything in Ray, sorry, in the Docker Compose, we can go to Ray's dashboard. So let's check it out. So you should be able to see something like this. This is Ray dashboard. Okay, we have this summary of jobs and events, and also the nodes that we are using, the resources, and here in jobs right now, we shouldn't have anything because we are not running anything yet. And we can see that we should have 3 alive nodes, which is raise head, as you can see here, tagged as head, and the 2 worker nodes. All right. Okay, so that's basically it. In the logs, since we have a local configuration, it won't show the logs of the jobs, but in a development or production environment, we can configure where to store the logs, which is usually, like an external bucket or something like that, not in the internal machine. And we should be able to see the logs of every task that is executed, okay? All right, so we are ready with introduction. So we can close this and we can go to Smallpond. In the case of Colab, in Smallpond Colab. All right, so now, here what we are gonna do first, we are gonna import everything that we need. All right, so let's run it. Remember that even though I'm using this Jupyter notebook, I'm using the environment that is here, okay? This dot VM environment. So if you're used to use Anaconda or something like that, then you need to install at least the requirements that we have here in that environment. So you will be able to run everything. Otherwise, it's gonna fail. Okay, we need to have set up everything that we need for this environment. Okay, so we have the import. This is just a double check that we are able to run DuckDB, okay, in our environment. So we are just creating a simple data frame, a pandas data frame. This is also an example of how flexible DuckDB is, because using this DF, we are gonna create a select query, and we're just gonna point to the variable that has our DF like this, and we are able to run DuckDB SQL. Okay, so it works. Now we're gonna check that. Okay, so we know that Ray is running, but we need to double check that we are able to reach it out through code, and that we are able to initialize Ray. This is very important because every time we want to use a Smallpond, we need to first initialize Ray. Okay, so we're gonna run this. Okay, I'm getting some this version. This is, as I said before, this is very important. The versioning, not only in Python, but also in Ray's version. So here perhaps, yeah, mistakenly, sorry about that. In the requirements, in the last requirements that I created, I added a Ray's version that is not the correct one. So I'm gonna stop the kernel. Okay, let's gonna close this so we can run it again.
Okay, just
Okay.
quick thing. So if I see there are people who run in the same issue, so in this case, you need to manually adjust Ray version in requirements.txt. After the workshop, we're going to fix it, of course, that it stays like proper on the GitHub repo. But for now, please just manually adjust Ray version to 2.35.0 in your requirements.txt.
Yes, please.
And don't forget, of course, to restart the kernel. Otherwise, it's still going to point to the wrong version.
So yeah, we can just run a uv add Ray equal 2.35.0. Okay. All right. So now we should have the correct version of Ray, and we're gonna start our Jupyter notebook again. Okay. Notebooks and Smallpond. All right, let's run the imports again. The double check, and let's try out the initialization. Okay, now it's running correctly. We can see current Ray clusters resources. Okay, in this case, since I didn't configure either Ray or Smallpond with a limited amount of resources, it is just showing all the resources that it sees available in this machine, okay? But we can limit, we will limit after this. In a Smallpond, we will limit the resources that it's gonna use, okay? And just for a double check, we're gonna execute some simple Python code, but distributed, let's say, in Rays, okay? So let's run it. That's it. So we do have results. So Ray is correctly communicating with our Jupyter Notebook environment. We have compatibility. And at the end of this check, I'm shooting down this Ray's initialization because we are gonna do it again after with some Smallpond tests, okay? All right, so now we can go to test MinIO. You can see here that we're gonna interact with MinIO in different ways, okay? First way was in the UI. We were able to create a bucket, upload a file, everything. Now, this is another way to interact, which is through the SDK to the library. We can just authenticate like this. and we need to point to the correct URL, right, where our MinIO is. And we are able here to create a new bucket. If it doesn't exist, then it will create the bucket. And then it will upload our sample parquet. Okay, we're gonna see what is in the sample parquet now. If you go into any issue of the path of the parquet, uh, one option is to have the full path to your parquet file. So it will mean to have the username and everything of your local computer from root to the parquet file. So the full path of your file if you run into any issues. But since we are here inside the workshop folder, you should be able to access the parquet file, right? So let's see. Yeah, here the parquet file is right here in the notebooks. I added here just to make it really easy because we are running the notebooks in the same place. You shouldn't have any issue. But if you put the file somewhere else, like in data or somewhere else, then you can just point to the full path of this file, okay? And if we see the file, let's open it up. This is a parquet file with the data of pods. Like if you have a Kubernetes cluster with multiple machines, this is basically when these machines run, what model, what serial number it has, in what date they run, if they fail or not, which is the data center where they run. And then we have some metrics about how they run um, in the cluster. Okay, we have a lot of columns, lot of columns. Some of them are null, some of them have information. It is a very simple and small parquet, okay, because we also don't know. I mean, it's okay if you run this array cluster in a small machine. That's also, I wanted to show part of the flexibility that you don't need to have 64 gigas of RAM or something like that to run this. But if you are using a big parquet or multiple big parquets, then perhaps you're gonna need more resources. So this is a small parquet, so everybody could run it easily and see more that the functionality of Smallpond, okay? So in the practice, we are gonna see that we are gonna filter by some of these fields to have an idea of the functionalities of a Smallpond. But for now, we are just gonna load the file and upload it to our storage system, okay? Create the bucket, upload the file. Let's see. And okay, yeah. So basically, it is saying that we already have the bucket. In my case, I already have it. If not, then it should create it. And the Parquet file was uploaded. Let's remember that in all these storage systems, if you already had the file and you upload it again, then it will just overwrite the same file if it has the same name in the same root. Okay, so now we have, this is also very important to have it ready here in my data. and then data and sample parquet. We have it here. As you can see, we just uploaded it because this file is gonna be used in the practice. Okay, so we need to have it here. All right, so we are able to reach MinIO. We are able to have the parquet file, all right? And then we're gonna see here another way to interact with MinIO, which is the classical AWS S3 way to ingest a file or write to a file, okay, directly with this notation, which is S3 2 points slash slash, and then the root, the path of the file, okay? So in order to be able to use this notation, we first need to have the credentials as they were AWS credentials, because this is using 3FS, but with S3 directly, okay? So we're gonna run this to have the credentials in my environment. That means that if I go directly to the command line, we should be able to show these credentials, okay? And since Smallpond uses PyArrow, then we are gonna read directly from here. You will see that this is another limitation of a Smallpond. I mean, it uses PyArrow, and we can load Parquet files from the local machine where we are running Smallpond, but we cannot use directly from Smallpond library. We cannot use this notation. So that's why I'm first loading it with PyArrow, and then I'm gonna use it like this from Arrow, okay? So we're gonna read the Parquet. Okay, now this means that we have downloaded from our storage system and loaded to a table, okay? And from here, we're gonna test, finally, Smallpond, okay? Just so you can see here that, okay, I'm gonna move this shoot down to the end. I'm gonna create another cell, okay? So it doesn't shoot down right away. Okay, and first we will initialize Ray, and here very important, we want to point our Smallpond to the Ray cluster. If we don't do this, if we actually just use the Smallpond init like this, then what we will have is that Smallpond will create a Ray cluster, but the local cluster with just one node, so basically just the Ray head, and it won't be distributed, okay? But it will work. So if you're running in Colab, you will see that in the Colab code, it is just like this, because it's gonna create its own Ray cluster, but very small, not distributed, okay? So like this, we will point to the correct Smallpond. Then, as you can see, we always have a data root, which is the transition place where Smallpond will write the data of the results or the intermediate steps of the tasks. And we can see this data folder here, is this one of here. We will see that when we run this, we will start seeing how folders are gonna be created there, and with some checkpoints and some results. And then we can define, in this case, we have two executors. I have this bin numa node false. This is very important. I mean, the numa bin is basically to use GPU. In my case, I don't have GPU in my local machine. So I have it disabled. And after we run this, I'm gonna say a few things that I found by running it in other configurations. But yeah, basically, if we want to run it in CPU, is like this: disabling NUMA. And here I just set up a little bit of the resources that we want to use in our workers. Okay. And then simply what we will do is to read the data set in arrow that we already have and print it out. So let's run it. We can see that Smallpond is initializing here. Okay. Awesome. And if we go to jobs dashboard, you can see that the session is running. This is actually the session. Okay. Okay. Let's go to the here. Okay, we have an error. Let's see. Get to create. File not found. Okay. Open. All right, so it is complaining about the place where Ray is putting, or Smallpond is putting the checkpoints of the tasks. Okay, this can be because now we are running it from this Jupyter notebook outside the, like exactly inside the workshop and notebooks. Okay, let's check it out. If we see, here it is the data and sample parquet is here. So it looks like it is running. Okay, maybe we are missing is notebooks place. Okay, let's see. So data. Yeah. So yeah, we're over here. We're over here, and the data was outside. And since we are running from this folder, then it is creating a new data place here. And it is not shared. The thing is that that's not the one that is shared here. Okay, so let's go. Sorry for these errors, but I think it's good to also have errors and debugging, so that we can really understand how it is all configured and connected. Okay, so basically we are gonna have to run our Docker again, and we're gonna change this to notebooks data. This is the race data folder. Okay, let's go here to in every array node in the workers and the head, we're gonna change it. All right, and we're gonna remove the Jupyter notebook, and let's rebuild. It's here. In my case, it's here. So we're gonna rebuild our Docker Compose. Should be pretty fast because we only change a folder, but all right. So let's run again the Jupyter notebook. Workshop notebooks and Smallpond. All right, let's run it again. Checks. We don't need to run again the initialization because we already tested. And if you check it out and you already have the my data sample parquet, you also don't need to run this test again. Okay, so we can just test from Smallpond test here. We load the parquet file, and this remains the same because we are pointing it out from race service. From race machine, it is just data, but from outside, it is another. So let's run it. It should work now. Okay, doesn't want to. Yeah, same issue. Okay, let's double check in the race head. Let's see if we have the shared. Go to the command. Let's see this one. Okay. So I'm gonna enter race head here. Okay, you can enter like this, except -AT race head bash. Okay, so we can see that we do have data. Let's see, cd data. It is created, but it is not letting us point to that. Let's see. So basically what happens is that both our outside environment, which is this Python environment with Jupyter Notebook here, and all the services, at least all the Ray services, they all need to have access to the data folder. If only the Ray services have access to the data folder and not the Jupyter environment, or at least not in the same address, then that's where it fails. I faced it before, and actually it was a pretty tricky because there's not so much information on why it happens, but let's check it out. We should be able to map to the same place. Okay, so maybe if I use the full because in theory data. Otherwise, what we can do, I mean, I placed the notebooks inside the folder notebooks to make it look order, but we could also put it outside so that we don't have this issue because everything is, as you can see here, the Docker and Braze and everything is here in the root. So fastest fix that I see is to get back to where it was and just putting the notebook outside. Okay, can exit. I'm gonna shut down this.
And while we're doing the live debug session, I just want to say we have 10 minutes. So let's see what we can cover.
All right. I'm gonna very fast move this, and if we have still errors, then I will just move into the Colab part, which is, I mean, it's pretty fast. The other one, so I think we will ever. Okay, so we're moving it outside. The same with practice, we need to move outside to workshop. So we have them all outside now. And I'm gonna rebuild. Okay, it's running. All right. So pretty quickly running the Jupyter. There we go. Workshop. And now we have it outside here. So let's go. Let's execute this and then write to Smallpond testing. And let's cross fingers. Okay. Okay. Now it is in rebel mode. Doesn't want to. Okay, but that's the issue. In the case you, I mean, I'm gonna double check this and I will update the repo so that you can make it work at home, and also we'll be able to resolve any questions. But basically what is happening is that this data that Ray uses for checkpoints needs to be exactly the same root and needs to be able to refer to the same folder as we have here in the Jupyter notebook environment. Okay, that's basically it. Maybe also, yeah, basically is that I moved the the folder of the codes. I mean the codes in the different folders to make it look ordered, but that break it down. So so if everything went fine, you should see here a green task that didn't fail. As I said before, we are not able to see the logs because it's not configured, it's locally only. But it should also print here the result of taking the first 10 rows of our parquet file. Okay. So I'm gonna shut down race, and now I'm gonna open up the practice. Okay. And so for this, we are just gonna see some of the equivalents of pandas to Smallpond. So as you can see here, let's see, okay, this here, since we didn't point to the array cluster, it created its own local RAID cluster. Okay, so once Smallpond has started, we can read, for example, parquets this way. Let's see. We should be able to read the sample parquet, as you can see here. All right. Then we can also convert a Smallpond dataset to a pandas data frame like this. So we can see that now has the pandas structure that also says the rows and columns. And we can also write the parquet, the data set as parquet file. Let's see, why is it complaining? Okay, yeah. I was putting the same as in Smallpond. Okay, like this. So now we have new parquet file. Here in notebooks, here we have the newly created in pandas, and the same we can do with Smallpond. But Smallpond, we create a folder with the manifest, and inside the manifest we have the parquet that we are writing. Okay. Then we can see how we usually filter in pandas. It will look something like this. Let's say I only want to filter the machines that have model like this. So I'm gonna run this and we can see which ones are like this. And this is the way we will do it in Smallpond. Right, so we have this very ugly way to print it, but it is because it's a Smallpond data set and it's not formatted like in pandas, right? Let's see. This is the way we will map. So here what we are doing is summing two columns and creating a new column, right? So let's check it out. We have here the result of the sum of every row, and that will be a map here in Smallpond. And I'm translating to pandas so that it can look a little bit better. Okay, so we can see here the results. And finally, something very specific to Smallpond. There's a method called partial SQL, which is the one that actually takes the DuckDB distributed and let us execute every task partitioned by what if we don't set up manually the partition, then it will take the best partition possible. But if we set up the partition that we already know, for example, dates, or in this case, we are grouping by data center, then it will just lazy execute this. Okay, here in this case, we are not able to distribute because, it's the Colab version and we don't have the cluster. But in the case of you have the array cluster up and running, then it will execute there. And finally, the repartitioning is, once we have the results, once we have the new data set, we are able to save it in different ways to partition it. So this is actually the manually way to say, okay, I want you to partition by data center, for example, in 5 partitions. So this depends on your data and on how you want to divide the data to avoid skew data or something like this. So yeah, sorry for for the incomplete errors there in the execution, but I will definitely be able to change this, and you will be able to run it after this workshop ends.
No worries. Thank you so much, Valery. I would say it's like, you're just like everyday job. That's exactly what happens. If everything would be run very, very smoothly, I think it would be a completely different life, right? And although we have a lot of tools which can support us now, still we are facing these issues. So I would say for me, it still was very valuable, just you try to understand where it's going bananas, like what's the issue. And I think the pointers you mentioned, for example, with this checkpoints for I spent a lot of time debugging it until I understood what's the matter with that. So yeah, it's very, very valuable information. So folks, do you have, we already 1 minute over the time, very, very quickly to finish the session, because for Valery, it's just start of the day. I think she needs to work. Right. Today, yeah, we will let you go very, very soon. For us, it's end of the evening. It's almost 8:30 now. Any questions from your side to Valery? Just let us know. And while we're waiting, I will, if you have any questions, just let us know. And in the meantime, a quick announcement for the upcoming event. The next event would be in a hybrid mode. So there would be parts in person, parts let's say, online. It would be given by another very prominent female figure in Python. It will be given by Choke. So more information about her soon. And she's coming to Amsterdam to the JetBrains office to give this workshop for you. The date we will announce soon. We're just finalizing the last preparations. And a quick thing for December. For December, we will be streaming, of course, the PyLadies Con for you. So there are a lot of fantastic speakers in the beginning of December. Take a look there. It's your time to join it and enjoy watching all the beautiful talks. So far, I don't see any questions. I think folks, they're still debugging as well. So for now, I would say, yeah, we do promise, right, Valery, that we're gonna do this update. I wouldn't say we promise that all updates would be published today, because there are still work day for Valery and other things. But Valery, I think it would be very, very, let's say, good if it's possible to get by the end, for example, of this week, or by the start of the next week, would be very, very good. So you also have time. And you got also, thanks a lot for the session. Indeed, debugging is part of the job. Yes. Okay, so for now, thank you so much, everyone. Oh, we get gracias, Valeria. Muchas gracias. Fantastic. Thank you so much. So I conclude the session now and just ask Valery to stay with me 2 more minutes. Okay.
Awesome.
Thank you so much for joining.
Thank you, everybody.
Now. So, okay, the stream is finished. Let me quickly double check.